Hey guys, we are going to discuss this problem. So it's also a 1800 problem. As always, we are going to start with the example here. So in the input, we are going to have two streams. Both of the streams are composed by digits of either 0 or 1. Right? This is string A. This is string B. This string is um, strictly less or equal than this this string. So the length of this string is smaller than length of this string. So what we are going to do is to first find all of the substreams of this longer stream which we have here, right? This stream is a substream of this one, right? And this stream is this substream, right? This stream is this substream. And these substreams have equal length of the stream B, right? And we are going to calculate this function. The input of this function is the substring and the string B, right? This string equals to string B. And we are going to have the function is to find the number of different digits in these two streams. So for example, for this two stream, we have one different, two different. So the answer is 2 for this function. And for these two streams, this digit is different, this one different, this one different, this one different. So we have 4 different digits. So the answer is 4. So we are going to calculate these 4 functions and find out how many of them are even number. So this guy 2 is even. This guy is even. This guy is even. So we are going to output 3 here because we have 3 even answers for these functions. So how do we solve this problem? So first, the string size of the longer string is very big. So we cannot iterate all of these substreams and compare each of the digits. So what's the complexity of that naive algorithm? So first, we are going to iterate all of those substreams, which is n, and we are going to iterate all of the digits of each streams. So the length is the length of the stream B. So the overall complexity is n to the power of 2, n squared, right? So it's not acceptable. It works for smaller test cases, but it cannot work for all of them. So what can we do? So we are going to simplify the calculation of this function. So how are we going to do that? Let's see the um, algorithm here. So this algorithm is going to calculate the function here. So the input is two streams. One is A and one is B, right? And A count 1 here. We use this symbol to present the number of ones in A, right? It means the counter of 1 in the first string, right? And this guy here, A01, is the number of ones in the run place in A, right? For example, we have 0, 0, 1, 1, 0 as stream A, and we have 0, 1, 1, 0, 0 as stream B, so that the number of ones in A is 2, right? And the number of ones in the run place in A is uh, this this guy, right? This guy is 1 here, but it's 0 in B. So this 1 is in the run place. So A01 is 1, right? And A11 is on the contrary, the number of ones in the right place in A. So this guy is in the right place because it's also 1 in B. So the number of ones in the right place in A is also 1, right? And the answer we are going to have is 2, right? 2 means the number of run place digits, right? So the parity of this number is the sum of A00 and A01, right? So it means the zeros in the run place and the ones in the run place in A, right? If we add them together, its parity is the same with the function's parity, right? So, um, so we can get more information from given information. How do we do that? So this guy, which is the number of ones in A, is equal to the A01 and the A11, right? That means the ones in the wrong place and the ones in the right place. So we add them together is the number of ones. And also for B count 1, right? The number of ones in B equals to the ones at wrong place, add to the ones in the right place, right? And it also equals to the ones in the right place in A, right? Because in A, if the one is at the right place, that means it is one in B at that same place as well, right? And if 0 is at the wrong place in A, for example, this guy, if this 0 is at the wrong place, that means it is a 1 in B at this same place, right? So we can deduce this equation here. And we can transform this formula a little bit. We can put, let's see, we can put this guy at the left side and replace A11. We can replace this A11 with this 2, right? So we got this 2 here, and this guy can move along to here. So with that being said, we got a brand new formation here. So what are we going to do with this formation? That is this guy's parity, right, is equal to this guy's parity. Why? Because if both of them are even number, then if we plus them together, it's also an even number, right? If one of them is odd, then the answer is also odd, right? So the same applies to minus here. If we change the plus to minus, even number minus even number equals even number. Even number minus odd number equals odd number, right? The parity of these two guys are the same. And we can move this guy to the left side. So what we got here is n b count 1 minus a count 1, right? Equals to the answer we are going to have here. So this guy is the number of ones in B, and this guy is the number of ones in A, right? We can also change this operator to a plus, right? They will have the same parity we explained before. So the original question is simplified. So what we are going to do is to find all the substreams. And for each substream, we will count the ones in that substream. And we are going to compare the number of ones in that substream with the number of ones in the target stream, right? And if the sum of this number is even, then the final function's answer is also even. If it is odd, the final answer is odd. So we just need to count how many even numbers are there in all of those functions. So let's take a look at the code here. So first, we are going to read these two streams, and we initialize the counters. This is the one counter of A, right? And this counts the ones in B. And we iterate from 0 to the size of B. And if the digit is 1, then the counter increase by 1, obviously, and also for A, right? And the answer here is the final answer, the count of the number of functions that results in even number, right? So these two current two counters is the first substream and the stream B, right? So first, if it is a even number, then we increase the final answer by 1. And then we move on to the next substream. So as we can see, this is the first substream, right? And this is the second substream. So what has been changed from the first substream to the next? Only 2 digits changed. The first digit changes and the last digit changes, right? If the first digit is 0, then we don't need to change the number of count, right? Because we only keep track of the number of ones. So if the first digit is 1, then we should decrease the counter by 1 because we remove the first digit from the first string, right? And we must check the new digits which added into the next string, right? So if the new digit is 0, we don't need to change anything. If the new digit is 1, then we need to increase the number of the ones in the string by 1, right? So in this way, uh, we can keep a track of the substring. We use a count to keep track of it. And for each substring, we will check the sum of the number of ones in the substring and the number of ones in the string B, and check if it is even number. If it is, we increase the number. We increase the final answer by 1, and we're going to output the final answer. So I guess that's it. Thank you for watching.